Hello, everybody. Today we're going to go over 3.1, which is graphing polynomial functions part 2. Today I'm going to give you the actual concept definition of what end behavior is, basically everything you learned yesterday. And we're also going to do an activity on key features. Polynomials is all about key features, so hopefully you'll remember everything that we have learned throughout the semester. To get started with the concept, a polynomial is a function whose rule is a polynomial. The end behavior of a graph describes what happens with the function, and more specifically, the y values as x approaches the positive and the negative side of the function. So again, the end behavior is just basically describing the left side, how the function ends on the left side and how the function ends on the right side. And we're usually going to define that by using either positive infinity to say increasing, right? And we're going to be using negative infinity to describe decreasing. If you want to make it simpler than that, basically your function is going up or your function is going down. That's what positive and negative infinity means. So to give you a quick example, if I graph a function that looks just like this one, I can see that as I go to the left, my function is going down, which means that as x goes to negative infinity, f of x, which represents y, is going down, meaning it's decreasing, it's going to approach negative infinity. From the other side, as x approaches the positive side, your function goes up, so it's increasing. So in other words, the end behavior as x approaches positive infinity, let me write that in a different color, f of x, again, that's just y, f of x is going to approach positive infinity. Okay. Yesterday, you guys used vocabulary such as going up, going down, increasing, decreasing. It's the same thing. The difference is I'm using negative infinity and positive infinity. Okay. So the goal of yesterday was to kind of develop a rule so you wouldn't have to look at a graph. Looking at the graph is probably much easier because we can actually see how it ends from left and from the right. But if I'm just looking at the equation, we got to kind of develop a shortcut, right? A rule, which is what we did yesterday. So that is the essential question. How do you determine the end behavior of a function without graphing it? And here's my shortcut. Ms. Espen actually showed me this. So there's two guys. Okay. There's a positive guy. Or actually, hold on. There's an odd, this is going to represent, and this is kind of how I look at it. Let me rewrite the little guy again. So if it's even and it's positive, your guy's gonna be, your guy's gonna be happy. So both of the hands are gonna go up. However, if the guy is negative, his hands are gonna go down. And now you got to think of this, and you actually got to do it yourself. You got to think of this as the guy is facing the paper, okay? So this is my left hand, and this is my right hand. Left hand, right hand, okay? So pretend that that is you. Obviously, I'm not there. I'm not able to show it to you, but just pretend that is you. That's your left hand. That's your right hand. That's when it's even and positive. That's when it's even and negative. Now, when it's odd, think of it as if it's positive, you're an odd person, so you're half and half. So your left arm is gonna start down, your right arm is gonna go up. So when your function has an odd degree and it's positive, that's how it's gonna look like. And again, you're facing the paper. So this is your left hand, this is your right hand. And when your function has a negative leading coefficient, you just switch. Okay, so again, this is your right hand and this is your left hand. So by using that shortcut or the table that I showed you yesterday, what is the end behavior of this function? Well, we can see that the degree is odd, and we can see that the leading coefficient is negative, which means I am going to be using that end behavior. So the end behavior of this function, as x approaches negative infinity, y is going to go up from the right side, which means it's going to approach positive infinity. And as x approaches positive infinity, f of x is going to approach, so that is the right side, is going to go down, which means it's going to approach negative infinity. And again, that's just a little shortcut, a little trick for you to figure out, end behavior without graphing. All right. Go ahead and turn the page over. And take about 2 minutes. Go ahead and find the end behavior of that graph. At this moment, you can pause the video, and then whenever you guys are finished, just come back, unpause it, and check your answer. All right, let's go ahead and check our answer. So again, first thing I'm gonna do is determine my leading coefficient. Sorry, I'm checking one thing. And I see that not my leading coefficient, my degree is even. And I also see that my leading coefficient is negative, which means my guy is going to look like this. So as x approaches negative infinity, y is going down, which means it's going to approach negative infinity. And as x approaches positive infinity, y from the right side is also going down, which means it's also going to approach negative infinity. So hopefully you got that correctly, but that is how you're going to be determining the end behavior of any polynomial. All right, so at this point, you are going to be graphing two functions, all right? You're going to be graphing those two functions using the calculator. They're going to be polynomial functions, and you're going to find all of the key features of that graph. Now, I'm going to tell you there are some things that I really don't need you to find. I'm going to let Ms. Harmer know what those things are. But let me give you the two functions that you're going to be graphing. All right, so these are the two graphs that you guys are going to be graphing on your papers. Make sure that you read the directions. The directions say you're going to write the function in the correct space below. You're going to identify all the relevant information. If there's any information that does not exist, just say D and E, or just write D and E. But these are the two polynomial functions that you're going to be graphing. And again, you're going to be finding x, y intercepts. You're going to be finding domain, relative minimum, maximum, when the function is increasing, decreasing. So there's a lot of information. You need to at least be able to complete one of those functions, and the other one is homework. This is really, really, really important. Use your calculator. A lot of the zeros, meaning the x-intercepts, are going to be really ugly x-intercepts. So you're going to have to estimate them to the nearest tenth. Don't estimate them to the whole. Just estimate them as much as you can. Use the calculator. All of you guys know how to do that with the calculator. So other than that, I will see you guys on Monday.